this figure. So how many triangles are actually in that image?
1, 2.
I heard 1, I heard 2. I see 1. That's kind of shoved up in that top right corner. Here's the large triangle around the entire figure as I trace across it. In the right corner, there's a second smaller triangle. These are two similar triangles, and I'm going to use proportions to solve for x. But it's kind of hard to visualize because they're sharing some side lengths. They're overlapping with each other. Well, I can get around that by just redrawing them. Let's take a minute and just redraw these two triangles. Which sides correspond to? Just redrew the small triangle separated out from the larger triangle. In the smaller triangle, the top side has a length of 6, the left side has a length of x. In the larger triangle, added together, right? The entire distance from left to right is split into two pieces. One has a length of 4, the other has a length of 6, so altogether it's not just a length of 10. So between these two triangles, what proportion could I write?
8 over x.
So 8 is to x, all right? Finish up the second half of that. Sure. Did somebody write something different? But did we go to a different order though? Could I have done a different order and still been okay?
Yep.
What order could I have done? What if I did 6 is to x? 6 is to x as what is to what in the bottom triangle? 10 is to 8, right? As long as you're consistent across how you're setting it up, does it matter the order you write your proportion? No, you're going to cross multiply the same things anyway, so it doesn't matter, right? Zoe just said 8 is to x as 10 is to 6. Big is too small as big is too small. I went small to small as big to big. It doesn't matter. Here's a mistake people do make though. When they first start doing these, they're going to do, all right, 6 is to x as 4 is to 8. But is 4 really a side length of one of these two triangles? So it's like comparing apples to oranges. I can't go side length is to side length as a part of a side length is to a side length. That doesn't work like that. It's not a total side length. You gotta make sure I'm comparing the right things across these two triangles. So let's cross multiply. X times 10 is 10x. 6 times 8 is 48. Divide by 10. I think we're supposed to get 4.8. Is that right? Got it. Another one. It's pretty straightforward once you know how to do it. Put x in a little bit of a different spot, but the question is still the same. Here's two overlapping triangles. Find the missing length x. So let's just redraw these two to get a better understanding of what sides go with what. Got a smaller triangle shoved into that left corner. So I'm going to re-sketch that out really quick. Read x. Another larger triangle here to the right. One side length is 5. What is this entire side length?
4 plus x.
4 plus x. If we added 4 and 6 here, Shouldn't I add x and 4 as well here? Across the side length from left to right, it's x plus 4. Does that sound reasonable? So write your proportion. Get me started, Caleb. Pick a proportion for me. How can we set this up?
5 and 3.
So 5 is to 3. All right. Finish the rest up.
Is x plus 4 is to x.
Got it. Start cross multiplying. 5 times x is 5x. 3 times quantity x plus 4. Or the other cross product.
X plus 4.
Sure, you just distribute right away. Tristan says take 3 times x and 3 times 4 to get 3x plus 12. Bring down the 5x also on the left. What's next?
Subtract 3x from both sides.
5x minus 3x is 2x. All I have is 12 on the other. 5 by 2 and x is 6. One more. You guys do this one. So we're sure to get it. We've done a couple. Let's see if you can get this solved for. Pair of overlapping triangles is shown. I've got some side lengths of 7, 6, x, and 10. Write the correct proportion to solve for x in those pairs similar triangles. Be 14/3 when you're on.
I was just going to say, this.
That's fine. I just wrote it as a fraction. What's your decimal?
It's 14.
Yeah. Did you reduce 28/6 down?
Yeah, it is.
So it's 4 2/3.
Yeah. Isn't quiz 2 on Khan Academy just this?
We started solving some similar triangles yesterday. Here's just a little bit more complicated version of that. We're going to prove some more triangles starting tomorrow. What are conditions necessary to prove that one triangle is similar to a handful of conditions? Total.
Interesting.
You guys. Sketch the two triangles separately. What's this total distance from left to right? Good. is relabel all the other distances here. Small triangle has distances of 6 and 7. The larger triangle has a length of 10 and x plus 7. So write a proportion. I go 6 to 10. Set up the rest. I went left to left and good. You can really choose any pattern you want. I was thinking 7 is to 6 as x plus 7 is to 10. It's the same thing. Cross multiply. 7 times 10 is 70. Kira, what'd you get when you multiplied 6 times x plus 7? What's 7 times 6? 42. Good. Perfect. Looking good there. Subtract 42 from either side. What is that? 28. 70 minus 42 is 28. Divided by 6. 28/6 is reducible down to 14 thirds.